This video will go over problems numbers 13 through 16 from your 8.5 notes packet. So number 13, we've done several problems like this yesterday in class in notes. And remember what rationalizing the denominator means. It means that we're going to multiply the problem that we are given by something that will, when we multiply it with the original problem, will make this radical in the denominator no longer a radical. So we need to think about, since this is a square root, numbers that we can square root are numbers like square root of 4. We can answer that. It's 2. Square root of 9. That's 3. Square root of 16. That's 4. So we need to think of, there's a 3 right here, and so we can't square root 3 and get a whole number. But if we multiply 3 with another 3, then 3 times 3 would get us 9. And then we would be able to square root 9 and get 3. So that's how come we know to put a 3 here. Now, the index here is a 2. So 2 does not go into 5. So for those of you, evenly, so those of you who are visual, imagine this, there are 5 of these. And since the index is 2, we want nothing to be left in the radical. So those 2 would pair up, these 2 would pair up, but this last x needs another one. That's why we're going to put 1 here. So then this one will join and it would have a partner. So that's how we know to put an x in the radical there. Okay, so now that we've figured out what to multiply, we also need to multiply the numerator by that same quantity. The reason being is when you have the same thing over the same thing, this is the same thing as we're really multiplying by one whole. So that's why we're allowed to do this, because we're not changing the problem. So when we multiply with fractions, we go straight across. And then we would have the square root of 3 times the square root of 3. That's the square root of 9. And then we have 5 here, x times x times x, 5 of those. And then we have this one, which would make x to the 6. So if we did this correctly, this should no longer be a radical because we can evaluate it. The square root of 9 is 3, and 2 can go into 6 3 times. And then we check and make sure that the numerator can't be simplified further, which in this case it cannot. But remember, you always check if this stuff here could be simplified, which in this problem it cannot, so that is our final answer. In the next third example, you will see there are still radicals in the denominator. However, what you will notice about these next 3 problems is there's 2 things being added or subtracted, and at least one of them is a radical. So when we're rationalizing the denominator and we have 2 instead of just the radical 3, we're going to utilize conjugates, and we'll talk about why here in a moment. So if the denominator contains something that's being added or something that's being subtracted with square roots, you must multiply both the numerator and denominator by the conjugate. So the word conjugate is something we've talked about back when we were in chapter 6. So remember when we were working with polynomials, if we had x plus 3, the conjugate would be x minus 3. So we're keeping the first term the same and then making the second term opposite. So that's how we find the conjugate. So if we had 2x minus 7, the conjugate would be 2x plus 7. So that is what we're going to multiply in this problem here. So that the radicals in the denominator will disappear, we are going to multiply by the square root of 2. So we're going to keep this the same. And then since this is a plus, we'll have a minus here, and then we'll have the square root of 3. So that's what we're going to multiply the numerator and the denominator by, because remember, this is really only a whole. Alright, so we're going to go ahead and multiply here. Now when we multiply, we're going to have to FOIL here. But because these are conjugates, remember, this could be done really quickly. All we need to do is the square root of 2 times the square root of 2, which is the square root of 4, which is 2. And then all we have to do is the square root of 3 times negative square root of 3, which would be negative because a positive times a negative is a negative. And then square root of 3 times square root of 3 is the square root of 9. So we would get 2 minus 3, which is negative 1 in the denominator. And therefore, if we've rationalized it, it does not have a radical in the denominator anymore. So that was the shortcut way. Now, if you were to multiply the square root of 2 times the square root of 2, so I'm going to go back over why this works. Square root of 2 times the square root of 2 is the square root of 4. And then we'd have the square root of 2 times negative radical 3, which would equal negative square root of 6. Okay, so we're done with the first number. Now we are going to multiply the square root of 3 by the square root of 2, which that is the square root of 6. And then lastly we have the square root of 3 times negative square root of 3, which is the negative square root of 9. So here we get the 2, and then these two are going to cancel because we're going to have a negative 1 and a positive 1, radical 6, and those make 0. And then here we have negative 3. So 2 minus 3 is that negative 1 that we got using our conjugate method, knowing that these middle ones are going to make 0, rad 6. Now we're going to multiply the 6 times radical 2 minus radical 3. So remember, we need to put these parentheses because this was together here and because of that subtraction there. So we're going to go ahead and multiply 6 times radical 2, so just 6 rad 2, and then a positive 6 times a negative radical 3 is negative 6 rad 3. And then we cannot combine these because when we are subtracting radicals, the inside of the radicals must match. So we would have 6 rad 2 minus 6 rad 3 here. And then we learned in our last chapter that when we have only one term in the denominator, that we can rewrite it split up like this. And now we can simplify this here. Positive 6 divided by negative 1 is negative 6 rad 2. And then here we have a negative 6 divided by negative 1. That is positive 6 rad 3. And that would be our final answer. Our goal when we are asked to rationalize the denominator means we don't want radicals in the denominator. So what we're going to do is we're going to go ahead and multiply by the conjugate. So we keep the first one the same, and then instead of a minus, we'll put a plus rad 2. So that is what we're going to multiply to the numerator as well. And remember why that is, because this is like multiplying by a whole. So let's go ahead and start with multiplying the denominators. Since we picked the denominator, what we multiplied by was a conjugate, we know from previous chapters that all we need to do is do 3 times 3, which is 9. And then we would have this negative times a positive is a negative. And square root of 2 times square root of 2 is square root of 4. And therefore we would just have 9 minus 2, which is 7. So now we don't have a radical in the denominator anymore. So remember why this works to only multiply the front 2 in the parenthesis and the last 2 is because if we were to multiply this out, We're going to have a positive 3 rad 2 here, and then here we're going to have a negative 3 rad 2, which would make 0. That's why, that will always happen when you're multiplying with conjugates. So that's why we just have 9 minus 2. Alright, now let's go ahead and multiply the numerators. We cannot use the same conjugate method we just got done doing because these aren't conjugates. So we have to actually FOIL this out. So we have to do 4 times 3, which is 12. And then we have to do 4 times radical 2, which is just 4 rad 2. So we're done there. Now we have to do the 5. So the square root of 5 times 3 is 3 rad 5. And then the square root of 5 times the square root of 2 is the square root of 10. Alright, so this is what we have here in the numerator. So in other words, all of this is on top of 7. So this is an answer that we could have, as well as we could put that 7, since it's just one term in the denominator, we could put the 7 underneath each one, but that doesn't do anything because we can't simplify 12 sevenths, we can't simplify 4 sevenths, we can't simplify 3 sevenths, and we can't simplify 1 seventh here. So in other words, we can just leave our answer, so we could leave our answer like this, or we could leave our answer everything over 7. So here we're trying to rationalize the denominator. Again, that means there should be no radical in the denominator like there is here. So we've learned that if you multiply by the conjugate, which again means keep the first one the same, and then make it a negative if one's a positive, and then we keep these the same here. So if we multiply the denominator by that, we have to also multiply the numerator by the same thing. And the reason why that is, remember, this just equals a whole. So mathematically, we're just multiplying by 1 essentially here. So let's go ahead and start by multiplying the denominators. Well, we can FOIL this. Since these are conjugates, all we have to do is multiply the first two. So 2 times 2 is 4. And then we'd have a positive times a negative is a negative. And then we just need to do the square root of 3 times the square root of 3, which is the square root of 9, which square root of 9 is 3. And we'd have 4 minus 3 is 1. So in the denominator, we'd have 1. Now let's go ahead and multiply the numerator. So in the numerator here, these are not conjugates. This is a minus and this is a minus, so we have to FOIL this out. We cannot just multiply the 2's and the square root of 3's. So we're going to do 2 times 2, which is 4. And then we're going to do 2 times negative radical 3, which a positive times a negative is a negative 2 rad 3. So now we have negative rad 3 times 2, which is another negative 2 rad 3. And then we have negative radical 3 times negative radical 3, which a negative times a negative is a positive, and square root of 3 times square root of 3 is square root of 9. So now we're going to simplify. The square root of 9 is 3. So we can combine our like terms. We can combine a negative 2 rad 3 with a negative 2 rad 3. That would be negative 4 rad 3. And then we can put together a 4 with a 3, and that is 7. So we could put the 7 first, or we could put the 7 after. I prefer it first so it doesn't look like it's in the radical. So in the numerator, we would have 7 minus 4 rad 3. And since there's only one term here, we can write it as 7 over 1 minus 4 rad 3 over 1. And we would have 7 divided by 1, which is just 7. And then we'd have negative 4 divided by 1, which is just negative 4. And we would have this as our final answer. And we have successfully rationalized the denominator because there is no radical remaining in the denominator.